we have a problem here which says convert from quadratic form. We see that's given to us like this. And we want to convert that into what's called vertex form, which is a different way of writing a polynomial. And it basically looks like this, where you have the vertex in pretty obvious terms. There's h, the horizontal shift. There's k, the vertical shift. And when you have a parabola, like, I don't know, that, the vertex is just the tippy top point. Or if it's a parabola going the other way, like this, the vertex would be the minimum. Okay, whichever particular shape you're looking at, the method is going to be the same for finding the vertex and switching this standard form polynomial right here into vertex form. But I'm going to go over two methods. One of the methods is called completing the square. Okay, and this is, I think, what people are most familiar with. You've probably heard of this before, maybe you've seen it before, maybe you still know how to do it. The other method is called locating the vertex, and this is what I prefer because it is just a little bit simpler and, to me, more intuitive. So we'll go over both methods. I think locating the vertex will be a little quicker. So a little background as completing the square, and I'm just going to do a quick example here. If I had something that was just x minus 1 times x minus 1, see, this is x minus 1 squared. What would that turn into? Well, if you FOIL it out, you see x squared minus x plus 1. And then as you simplify it, it becomes x squared minus 2x, as we combine those like terms. Now take a look at this minus 2 right here, and compare it to the minus 1 right there. Notice that it is exactly a factor of 2 difference. Well, that's a clue that tells us how to convert standard form into a squared form, so to speak. So as we're looking at this formula right here, see that divided by 2? That's where that's coming from. Now, this particular little a right here, that deals with the fact that sometimes your polynomials have a quadratic coefficient. Okay, but let's just go through these steps with completing the square now. So I'm going to say, let's take a look at this polynomial right here. And my a term, the quadratic coefficient, is 16. The b term is negative 24. And the c term is 6. And I want to figure out what h is. Okay, we're going to do that. So h equals negative, no, what's b? B is negative 24 divided by 2a. And that is 2 times 16. So this becomes 24 divided by, looks like 32. And I'm going to reduce this fraction. I'm going to try to reduce this fraction. Let's see. 12 over 16. Oh, good. This is going to look nice. 3 over 4. Just lost my multiplication tables there for a moment. So we have h equals 3/4 when we plug in that formula. So let's get that over here. H equals 3/4. Now, step 2, what I'm going to do is expand this form right here. Remember, I'm going for a vertex form that looks like this. So we're going to go ahead and start writing that. F of x equals a times x minus h squared plus k. Except for us, we have some numbers here. A is actually 16. H is not h. H is 3/4. I don't know what k is. Let's hold on to that for a moment. That's our function. And I know that it must be equal to 16x squared minus 24x plus 6. Okay, that's what we were given. So the question is, how do I figure out k? How do I figure out k? Once I know k, then I'll have rewritten my function in vertex form right here. So now all we do is determine k by balancing the equation. Okay, so let's expand this term right here. We're going to say that is 16 times, well, what's x minus 3/4 squared? That's going to be x squared minus 3/4 x minus 3/4 x. That gives me minus 3/2 x. And then what's 3/4 squared? Well, that's going to be 9/16. Okay, so this is what I have on the left side. My right side obviously has not changed. I didn't do anything there. And now let's multiply this factor of 16 through the parentheses. I get 16x squared. A 2 crosses out, and this turns into 24x. 16s cross out, and this turns into 9. Okay, so hopefully you're noticing there's a lot of things here that are going to cancel out. Well, let's just take a look. I've got a 16x squared on each side. I've got a negative 24x on each side. And all I get left is this little equation, 9 plus k equals 6. Well, you can subtract 9 from each side. Okay, we're going to do a little minus 9 action here. And what do we get? We get k equals negative 3. Okay, so let's take that and put that over here. I'm running out of room a little bit, so let me clear some space. And now we're just going to write the equation, write the function in vertex form, and we're done. So here's our vertex form. I know k, I know h. All I have to do is say f of x equals, let's see, 16 times x minus 3/4 plus negative 3. So I'll just say minus 3. That's my vertex form. Don't forget the squared. Okay. Now, if you want to know what the vertex is, well, that's pretty easy. We've done all the hard work. It's just h comma k. So in our case, this would be 3/4 comma negative 3. Okay, there's vertex form and the vertex. Now, I promised you a little simpler way. I like locating the vertex. Instead of playing, there's a little less algebra involved here. So you see, I've already written down these terms that we figured out above. And let's go ahead and look at step number 2. Step number 2 is really the only difference here. But I like it. You can decide which way you want to do. I'm going to say k equals f of h. And this might seem a little weird, right? I mean, where did this f of h come from? Well, what I'm doing here, remember that graph that I plotted a little while ago? I've got a parabola. Who knows if that's the shape, but it looks something like that. And there's a vertex right here. And the vertex is located at h comma k. Well, what's the point of a function? The point of a function is if you plug in an x value, like that x value, h, it will give you the y value of the function, like this y value, k. So all I'm going to do is plug in h into my function, and what's going to pop out must be k by the definition of a function. So let's go ahead and do that. This is going to be 16 times 3/4 squared minus 24 times 3/4 plus 6. Okay, so that's going to give me, let's work through it, 16 times 9/16. Everything's going to simplify out just fine. Minus 24 times 3/4 plus 6. Now 16 times 9/16 is just 9. 24 times 3/4, I think the 4 is going to cancel out. We get 18, I think, and then plus 6. And then little simple arithmetic tells me we are looking at negative 3. Okay, so I like this method. It seems a little quicker to me and more intuitive. Just plug in h, you'll get k. And now we're back here where we can plug in h and k into our vertex form.